Hello, everyone. Welcome back to my podcast. I'm here today with Amber O'Hearn and Tucker Goodrich, some longtime Twitter friends, and I've had the pleasure of meeting Amber in person a couple of years ago. So, welcome.
Thank you, Rafi.
Hi.
So, I invited you guys on just because I love talking to you, but also because I think it's back in November. We, like most things, I guess, in our circle, starts on Twitter. And in this occasion, it was a discussion about satiation, satiety, or was it both? If I remember correctly.
I think
Well,
satiation.
they're closely linked terms, so let's go from
Yeah.
there.
Yeah, and I think we were discussing, well, we're discussing the definition of it and the relevance, as is most often the case, the relevance to obesity. And you two disagreed about the definition, I think, and probably about how it ties into obesity, if at all. So I think we should probably start with definitions. What do we understand by these terms? And just before we started recording, I was asking you guys to gently remind me which one is which, because I always get them mixed up. So if I do this in the conversation, don't be surprised. But so satiation is wanting to put the fork down, and satiety is the space between wanting to start eating again after your last meal. So I think we can start with that as a very, very basic definition and then go in deeper. So please have at
Maybe I
it.
could. Maybe I
Go ahead,
could
Amber.
try to represent what I think the disagreement was about, and then Tucker can correct me.
All right, perfect.
So what I was saying was that satiation is a behaviorally defined thing. So satiation is the the quality of stopping eating. So the more satiated you are, the more likely you are to stop eating. And when you have stopped eating, that is the same as satiation. And by that very behaviorally defined definition, it would be nonsensical to say, I ate past satiation. As a definition of, and it's related to what it would mean to say overeat, which I also think is kind of a contentious term. And I don't want to say that like we can't possibly find a meaning for it, but what I was maintaining is that the most sensible definition of satiation has to have that meaning. Otherwise, we get caught in um, ideas that lead us back to a model of obesity that I don't agree with, that has to do with calories in, calories out, for example.
I
Okay.
think that's a fair summary of where we were, and I think the disagreement that we had was that I do think that eating beyond satiety is a thing and is the root of the obesity problem. And so I mean, we're all familiar, for instance, with the phenomenon where you finish a meal and you're stuffed, and then they bring out the dessert menu, and you suddenly find that extra little pocket of your stomach that hadn't previously been full, and you manage to go have a dessert that you probably wouldn't have eaten if you hadn't, had that option. And in, the literature, it's pretty clear that they consider satiety to be a point at which you want to stop, but which you are capable of continuing if you get a stimulus that causes you to continue. And, which then gets us into this whole food reward topic, right? Which is, what is the stimulus that might, and I think in our debate, Amber, I made the point that what I think is a useful definition of satiety is eating to a point at which you are full, but which won't over the long term lead you to become overweight or obese, obviously.
So
And I
does
think that,
that
Yeah, that's
presuppose, yeah, so does that presuppose that the satiation point is the determining factor of how you accumulate fat? Is that the implication or am I misunderstanding?
yes,
it
that's the
is the
implication.
implication. Yeah,
That's
yeah. I
Okay,
right.
think that's a
okay.
perfect setup, and will help me explain in more detail why I disagree with that. Um,
Okay.
okay, so let me just make sure I'm understanding. I think you've said two things. One is that um, you you would be satiated. Just because you're satiated doesn't mean you're not capable of eating more, and that I wholeheartedly agree with, because that's it's kind of a counterfactual, right? So in philosophy, we would say something is a counterfactual if it goes against reality, and it's really hard to argue against counterfactuals, which is why one of the reasons why I like a behavioral definition, because it's what happened or didn't happen, and there's no arguing about what you could have done differently if you've done that thing.
Hmm.
And another thing that you alluded to, I think, in that I would also agree with, is that your capability or desire even for eating more may be food type dependent. So it might make sense, like, who hasn't as a child said, "I'm full, Mom, I'm full," or "I'm not full for that," right?
Yeah, exactly. No,
We
I'm full of
intuitively
broccoli.
know. Right, right, right. But the idea that I really want us to grapple with and examine more carefully is the idea that the reason that we are overweight is because we eat past satiety. And if you will allow me a bit of a divergence, I think it's relevant if we go back and talk a little bit about the difference between homeostatic regulation and control and how they're related, because I think it bears on definitions about adiposity and the relationship between adiposity and appetite.
Hmm.
So you want to go there?
Yeah,
Yeah,
sure.
sure.
Awesome. So regulation is the part of homeostatic control where you have a variable that is your body is trying to keep within a special narrow bound. And I actually might disagree with this, but the canonical example of homeostatic regulation might be blood sugar. So it's supposed to be kept within a bound, or temperature regulation is supposed to be kept within a bound. And that variable is the thing that's being regulated. Whereas control is something that happens in response to regulation. So um, if if blood sugar is being, or if temperature is being regulated, then you might have some behaviors about going inside or going outside that have to do with control, in order to keep that variable regulated. But going inside and going outside aren't themselves regulated, they're controlled. Does that make sense so far?
Yes.
Okay, so one, I think, of the arguments in the discussion of what how obesity comes to be is what's being regulated versus what's being controlled. And so the lipostatic model says that your fat mass is being regulated. There's like a set point of fat mass, and food intake is a control response to it. And it would be nonsensical to say that food intake itself is regulated, because obviously if you go out in the cold or you do a lot of exercise, your intake will go way up, or it'll go, like, the variation is completely dependent on keeping the variable that we care about, which in that theory is fat mass, should be regulated by. And I think that if you say that adipose is under control, you get into if you say that adipose mass is itself under regulatory control, then I think you get into problems and conundrums that aren't explained. For example, we all have had, or at least many of us have had, the experience where you seem to tightly defend this set point of adipose, and so that sort of argues for, oh, maybe it's under regulatory control. But then you change what you're eating, and all of a sudden your set point drastically changes, and you realize, oh, there wasn't really a set point for that, but that what appeared to be a set point is being defended for the purpose of some other thing that's actually being regulated. And so a second competing hypothesis for what's being regulated as opposed to fat mass would be, for example, metabolic rate or energy expenditure. And so you could say the reason that some people have high fat mass is because they have an inability to oxidize fatty acids very easily. So for instance, the carbohydrate insulin model would be one way of supporting that. They would say, if your insulin levels are high, you have to have more fat mass in order to maintain the level of fatty acid oxidation that is the thing that is subject to the set point. And so I would argue that it is not, I guess I fall deeply on the side of that energostatic model versus the lipostatic model for what's under regulation and what's under control.
Okay, that makes sense to me. So you use the terms lipostatic and energostatic, referring to energy. One being control, meaning the energy, so what you take in, as well as what you expend and what it goes to, because it can go to different tissues and have different outcomes. And then this lipostatic muscle, which is really an amount of fat per maybe the area of your body weight. Maybe it's related to that, let's say. So those are quite different. I don't have, is there literature on an energostatic model, or is this just a way to conceptualize it differently? Because I don't think I'm familiar with it.
There are several different people, but I think the person who is most associated with the energostatic model is Mark Friedman. And I think that he was actually a big influence for Gary Taubes and how he conceived of the insulin model, pretty much directly from Mark Friedman's work. Another person who is an energostatic model advocate is Stylianos Nikolaidis, if I'm pronouncing that Greek name right. And he actually called it the ischymetric model, but it amounts to the same thing, where he argues that actually metabolic rate is what is being defended, and did some experiments showing that rats will start eating when their metabolic rate that's outside of locomotion starts to drop, and they'll stop eating when it reaches back to the baseline level.
The set point.
The set point for energy expenditure. Yeah.
Okay.
Yeah.
Okay.
Right. And then Herman Ponzer's done a lot of work around that idea, looking at different populations and how they, the level of energy expenditure seems to be a standard human feature, right?
That's a really good point, a good connection. I haven't read Burn yet. Have you read it, Tucker?
Yeah, I have. And I've talked to him quite a bit also on Twitter, where else? And I mean, I started looking at that hypothesis long before he started writing about it, just because it has an interesting relationship with the calorie in, calorie out model, and the exercise will cause you to lose weight model, where one of the seminal early papers, which he mentions in Burn, was they looked at African-American women in Chicago, I think it was, and a group of African-American women, I think, in Nigeria. And the American group was obese and the African group was not. But when they looked at them, they had the same total energy expenditure, right? And similar activity levels. So that was kind of one of the things that got me to think, okay, exercise isn't the cure to obesity. And Ponzer in Burn hammers that point home with a very big sledgehammer. It's an amazing book. I mean, if you're interested in the topic, he kind of goes off topic a few times, but when he's on topic, it's just absolutely required reading. But yeah, so there's definitely, I mean, I think there's truth to both of those models, right? There is a lipid set point and an energy set point, and they're related. So one of the Kevin Hall's neat studies was looking at what happened to the people in the Biggest Loser TV show. And
Yeah.
what he found was that their weight loss, and this is a common finding, that their fat mass loss was associated with a reset of their metabolic expenditure, their energy expenditure, as the body was trying to defend the fat mass, right? It's got a couple of dials that it can turn. One of them is to make you hungry so that you want to eat more. And another one is to turn down your metabolism so that you're, expending less energy.
Okay, so is it plausible to have two set points? And if you have two set points for two different things in this case, what is controlling them? So if energy, according to Amber's model, the Energo model, is the control for the fat mass set point, can the fat mass be controlling the energy expenditure set point? Like, can it go both ways?
I think it's emergent.
As an engineer, there are lots of systems that you see that try and optimize on two different variables. The body obviously tries to optimize on hordes of different variables. Those are two, clearly, especially in primates, fat mass is very important, for reproductive success, as well as being able to survive famine. So that's something that the body's going to optimize for. And as a warm-blooded creature with high energy expenditure requirements, we have to, make sure that we're expending a appropriate but not too high or too low amount of energy.
Mm-hmm.
I mean, one of the interesting points that Ponser makes is that when you, since you basically have a limited energy expenditure budget each day, when you go over that budget or push towards going over that budget, the body dials back other systems, right? Immune function is surprisingly one of the first things that gets dialed back. That's obviously not a long-term successful adaptation, but it's certainly super beneficial in the short term, or it can be, obviously.
I guess I have two responses to that. Gosh, I can't help myself but to respond to the immune thing first, because it's really exciting to me. Because one of the things that I think Siobhan Huggins has been discovering or rediscovering is that for some people, eating a very high fat diet seems to enable them to lose weight better. And why might that be? And one of the reasons that she thinks that might be is that it allows them to have the energy to support their immune functions to cause some healing to occur, such that they can then lower their insulin and then lose weight.
Wow.
But the other thing I wanted to respond to was the idea about defending two set points. And I agree that we have a lot of simultaneous set points going on, but I think that the more set points that we have, the more complicated it can be. And if there is a simpler explanation, then maybe there's reason for going with it. And one thing that I think happens with adipose tissue as a set point is that we don't really need to explain it as a set point, because it directly feeds into an energy expenditure set point in the fact that, so take away the unhealthy situation and imagine a person who's basically healthy metabolically. The more fat that they have, close to linearly, I think, the more fatty acid fluctuation release into the system they will naturally have. And so basically you can, when things are working very smoothly, you can control fatty acid oxidation simply by the amount of adipose tissue that you hold. And so it can look transparently in the healthy case exactly like a set point. And it only becomes confused when there are things that are inhibiting fat oxidation that don't have to do with, that either have to do with how much is being released, so an insulin sensitivity problem, or some other thing that is breaking your capacity to burn fatty acids, would also make it so that you have to hold more fat mass in order to supply enough fat to initiate enough fatty acid oxidation to get to that energy expenditure set point. And so I guess what I'm saying is that I think you can get fat mass, something that looks like a fat mass set point for free without having to actually have one. And then as a bonus, it explains why a set point can change when you do things like change the proportion of carbohydrates that you're eating, or maybe something to do with energy expenditure that could be explained by fatty acid profiles, for example, or something else. Another thing that, an idea that comes
Yeah,
up is,
if I
yeah,
could
go
just
ahead,
before you just to
before I
agree
launch
with
into
that
something
point.
else. Yeah.
Yeah, well, one of the two interesting hypotheses for obesity that I think are operative here. The first one directly gets into the carbohydrate issue, and it's the respiratory quotient, RQ, which is also called the respiratory exchange ratio, right? So so RQ is a measure of what substrates you're burning, fat versus carbohydrate. If keeping it simple, if you're at 0.7, you are burning all fat. And if you're at 0.1, you're burning all carbohydrate. And most people are somewhere in the middle. Your body has the capability to use both fuels at the same time. And that's where you're supposed to be most of the time. If you go on a ketogenic diet, you're going to be at 0.7. But what's really interesting is that if you're at 1 all the time, and there are people who are at 1 all the time, that predicts future weight gain, right? So, and it makes perfect sense because any normal diet is going to have some amount of fat in it, and your fat storage rate is 100% of, the fat that you eat and don't burn. And if you're never burning fat, then every little bit of fat that you are eating is going to get stored. So, an RQ of 1 predicts future obesity, not surprisingly. That's a fairly simple mechanistic explanation of why somebody could get overweight. And those are the folks who wind up, running out of glycogen in the middle of the night and having to get up and go raid the refrigerator for carbohydrates because you don't have that much carbohydrate, and they literally run out of fuel, even though they may be grossly obese. So that sort of gets to that point. I don't know quite what the interaction between that and a set point model is. That's sort of, in my view, a special case, right? There are actual physical changes that happen to people who have a RQ of 1 high enough to stimulate that behavior. One of them is that the lipid particles in the cells actually move away from the mitochondria, so that the mitochondria are literally not able to access fat for energy on a cellular basis. But anyway, so that's one little case that I think doesn't necessarily immediately relate to the set point, because those people are overeating basically because of a mechanical dysfunction, is how I would interpret that, right? They're not getting enough exercise. Their fat burning capacity is atrophying, literally physically atrophying, and they are left with this state where they have to overeat just to get fuel to operate the machine every day.
So it's compensation.
What do you mean by overeat?
Meaning they're over consuming fat, because every food has fat, or virtually every food has fat, and they are not burning that fat, right? So it's the drain plug is the drain plug is plugged and the bathtub is overfilling. They literally can't burn off the fat.
So
and I think one thing we all agree on is ultimately, if you're going to lose fat, you have to burn it off.
But I guess what I'm trying to get at here is, what is the difference in your view between overeating and gaining fat, or is there one?
What is the difference between overeating and gaining fat? Well, I guess the definition of overeating, those people are overeating fat because they're not using it. They're not overeating carbohydrates because that's the only fuel that they're capable of using. So they're pushing, again, they've got two variables there, and they're pushing one variable because they have to, and the other variable is getting carried along because everything that they eat contains fat, and yet they're not able to use it as a fuel source. So it's just building up and building up.
Okay,
So overeating is
yeah.
storing fat.
I would say storing excess fat is a symptom of overeating, yes, which is, I think, where we were at this on our Twitter discussion.
Right, which is why I stopped you right there.
But don't we say the same about diabetics, that there's too much fuel in the blood, and that if they ate less, this would improve? So it wouldn't just be in the fat mass, it would also be pertinent to the blood compartment, if I'm getting that correct, right?
Unused
yeah, and
fuel.
Certainly one of the symptoms of diabetes is excess fat in the blood, right? And I think there's an overlap between what I would call this simple mechanical model of RQ and diabetes and obesity. I mean, how could you become, how could you get into this state where you have this mechanical problem? I think it was Lustig did an amazing study years ago where he looked at these kids who had a brain tumor that caused them to produce excess insulin. And when he gave them an insulin blocking medication, the name of which I can't remember, the first thing that happened was when their insulin levels went down, their activity levels went up, right?
Is it diazoxide? Something like that?
I really can't remember. Don't even bother trying to. I remembered the principle, not the name of the drug, because it really doesn't have any relevance. It's apparently quite a harmful drug. It's not like you can go buy it at the pharmacy. But, it suggests that if you have hyperinsulinemia, that would suppress your activity potentially to the point where you run into this mechanical problem that I would consider kind of an outlier for most cases of obesity. That wouldn't be why you would gain the initial extra weight. It might be why, once you're already sedentary, you continue to gain weight past a certain point.
So just to take sort of an example, say you're a bodybuilder, and you want to take steroids and you want to get bigger. Are you overeating, or are you eating to the level that is necessary given that you've changed your set point with exogenous drugs?
Well, are you overeating? I guess if your goal is to become a bodybuilder, then no. Or probably an even better example is if you want to be a sumo wrestler who are, defined by excess body fat as well as big muscles, I mean, pretty much by definition, they're overeating, but they want to be overeating and they are putting on excess fat. It's just intentional rather than like most people, an accident.
So,
I guess I can't really get on board with that definition of overeating, because to me it seems like you're always eating exactly the right amount.
For a stated goal, yeah.
Right. But unless your goal is to be obese and you've become obese, what term are we going to use to describe that level of intake?
The person's goal, I mean like the body's goal. If the body's goal is to have sufficient energy, then you're going to eat until you have sufficient energy. And doing so isn't overeating, it's eating exactly the right amount. But at the same time, you're losing calories to your adipose tissue or just to the bloodstream or somewhere where it's not contributing to energy expenditure. And so it's analogous to going out and doing a bunch of, or instead of exercise, for example, going out in the cold, suddenly you're losing a lot of calories to heat generation, and now you eat more to compensate. You're not overeating, you're eating just the right amount. And I think that if you're losing calories to heat or if you're losing it to adipose, either way, it's the same situation.
Right, but then we get into a normal, and even with weight, there's a normal, healthy situation. So for instance, a pregnant woman puts on fat mass, right? That's normal. She eats to that goal. And then there's the pathological situation that most of the world is in, where they are eating way past any physiological goal that their body could have. I mean, nobody needs
But
700 pounds unless you're a
I think I
sumo wrestler.
disagree with something that you implicitly stated, that the pregnant woman's goal is to gain fat mass. That might be a goal in some sense. It's useful, but the goal of the body is just to maintain energy expenditure. And a separate goal that the body is doing is storing away fat. And when the body is storing away fat, then you require eating more to maintain energy expenditure. So I wouldn't say that the woman is
they're not
overeating
separate.
to attain a goal of storing fat, but rather she's storing fat, and now eating just enough has to be more.
Right, but it's not two goals, right? She's eating more to store more fat to enable future energy expenditure in light of expected future demands on
I'm not
energy
sure who you mean by
expenditure.
she, because I don't think that she is deliberately doing it, right?
Well, pregnant women are generally referred to as she.
But when you say she is doing it in order to gain fat, I don't think that a woman decides I'm going to eat more so that I can gain more fat.
Right,
Rather,
it's not conscious.
Yeah.
It's a physiological process controlled by the hormones.
Right.
So the woman's body has received a signal telling her that, given the now pregnant state that she's in, her energy needs are going to change, right? Do we agree that that's the main?
I don't agree with that. I agree.
Okay.
Here's how I would say it. The woman's body gets a signal to store fat. So her body starts storing fat. But that is independent of the goal, the set point of energy expenditure that stays actually exactly the same. And so because her energy expenditure needs are the same, and her body is meanwhile storing off fat, now she needs to eat more in order to respond to both of those, to respond to the body storing fat and the ongoing energy expenditure needs that have not changed.
Okay, so she's not storing more fat by changing the energy expenditure. She's keeping the energy expenditure the same and eating more in order to store fat.
Right.
So can we
yeah. Sort of.
Well, I've never looked at the question honestly, but I would be shocked to hear that a pregnant woman has a static energy expenditure going through pregnancy.
I'm not sure. I don't think I would be shocked.
I would be shocked because your body mass is increasing by the weight of the baby that you're developing, right? And if, as Ponsler has said,
energy expenditure. Total energy expenditure, of course. But like if you're going to measure it by a per cell or something like that, energy. I don't think we have a static energy adjusted. Yeah.
Okay, mass adjusted energy expenditure. Mm-hmm. Right. And does that make sense to talk about it in those terms, Tucker? Or do you think that's like...
Yeah, sure. I mean, if you don't include, if you don't account for the baby, then yeah, that's probably true.
No, accounting for the baby, specifically by mass adjusting it. That's what we mean. So, for example, her body temperature would remain within the normal range because she weighs more.
Right, that's what I mean. If her calorie count is 2,000 before she's pregnant, it goes up to say 2,300 when she's at 9 months because 300 of that is the baby.
Right.
Then her energy expenditure is constant, even though the absolute number's gone up. Of course, there's only one mouth involved, so in eating at that point, so she's got to eat more.
Right. So where does that? So to try to tie it back to the initial point about overeating and how that leads into obesity. So I know that Ludwig had an interesting paper, I think it came out in 2021, where he was looking at the energy available in the blood and how that may signal to certain parts of the brain that sample the blood, essentially, to signal certain energy availability, which would then drive behavior, right? So in that model, you have, I think it's a model that's closer to the energostatic model, essentially, if I understand it correctly and try to make the link with Ludwig's work. Do you view that work differently, Tucker? Do you think it can fit into a lipostatic model if the brain is sampling the blood energy and then deriving behavior from that?
Well, I think a more interesting study looking at that question is one that Kevin Hall did. Just since you're bringing in Ludwig, I'll bring in Hall, and they can duke it out here on our discussion, just as they do in real life. He gave people an SGLT2, I think it is, inhibitor,
Right.
so I think semaglutide, which causes an alteration in the kidneys such that you start peeing out sugar. And this is beneficial for diabetics and also for cardiovascular disease. And it's a completely unconscious, arguably unnatural process for this to happen, right? It's caused by this drug. So his question was, if people were unconsciously peeing out calories, what would they do? And it turns out they compensated for it by eating more, right? Mm-hmm. So that's a pretty neat demonstration that at some level there is an energy regulation system going on. In that particular model, they were, peeing calories out of their blood. I don't recall what the effect of that drug on body weight is, but yeah, clearly there's some sort of energy regulatory system in the body, right?
And
there are a few different ones we know of. So energy availability sampling is one way that you might be able to get a signal for that. You can get signals from the liver about fatty acid oxidation through the vagal nerve, I believe. You can also have the hypothalamus sample and then generate and see how much there is, or you can have some kind of some consequence of energy expenditure that happens that can send a signal because your body will infer that energy expenditure happened. So those kinds of signals would be reactive oxygen species, and that might be the key to the ROS theory of obesity, right? Because if ROS is signaling how much energy was expended, and you do something that sort of artificially is the wrong word, but artificially lowers ROS generation, then your brain might not perceive that as enough energy expenditure. AMPK is another one, and adenosine is another one. So that there are all these sort of so the energy availability, how much glucose is in your blood, for example, that would be a kind of pre-signal, and sampling it and seeing how much energy you get might be a kind of in tandem signal, and then sampling products of energy expenditure might be a post signal. And maybe there's some kind of integration that takes into account all of those.
Which is all speculative at this point. I've never read anything on
I'll send you links to all of those.
how it's done, that we know what the system is. I mean, Peters-Ra's theory of obesity is very interesting and one that I'm very familiar with, but it's not been demonstrated that it is operative in humans in real life.
You mean the integration or some of the specifics systems that Amber mentioned?
Well, I mean, everything that he describes, Peter sticks very close to the evidence, and everything that he describes is, accurate, I think. Is that what's driving obesity because of what you're eating? I don't know. There are other pieces of evidence that suggest that it's not, definitively not, the only thing that's driving the system, right? Yeah. Which gets into things that can throw your energy homeostasis system off. Hypothalamic injury is a great example, right? If you get a tumor in your hypothalamus, one of the symptoms, or a physical injury to your hypothalamus, it can cause massive hyperphagia, resulting in massive obesity. And it can be pharmaceutically controlled, but it's clearly indicating that there is some overall regulation going on, and that it's possibly to physically alter that regulation via point injury.
But
Right,
I
and
think
that
the content.
supports
Yeah.
the
Go
that
ahead, Emma.
supports the model where you've got the hypothalamus running kind of a simulation based on the inputs that are in the bloodstream, saying, okay, suppose the whole body essentially has this available. What happens when we burn it? You can't do that if the hypothalamus is damaged.
Yeah, and I think it's important to note that, because you said hypothalamic injury leading to hyperphagia resulting in obesity, but again, is it the injury to the hypothalamus that is directing fuel towards fat tissue, and then the hyperphagia accompanies that to actually make up for it?
Well, I wouldn't say directing fuel
again.
towards fat tissue, because there's only a few places where you can put excess energy in the body, right?
Mm-hmm.
I don't think, I don't know where, I don't think it's under the body's control or the hypothalamus's control as to where energy is going. It's just, you have a system for energy storage, and if you are eating excess energy, you are going to fill up those reserves. We have a limited amount of carbohydrate reserve and a massive amount of fat reserve. And when carbohydrate reserve is full, then it shifts over to fat reserve. There's
Why wouldn't you heat up, for instance?
Well, that is the only thing that the body could do to control it, would be to turn up the thermostat, right? With carbohydrate, there are other disposal pathways.
Or it could make
feel
expensive
like going
muscle.
outside.
Yeah.
I don't think there's any evidence that eating excess calories goes into muscular generation absent a stimulus like weightlifting or exercise.
Well, it depends what myostatin deletion you have.
Yeah, that too.
Well, I mean, somebody asked me once, how do I,
right.
How do I gain body mass to look like a weightlifter? I said, you act like a weightlifter, right?
Mm-hmm.
I mean, there's nobody with hypothalamic injury who winds up putting on solely muscle mass. It's always fat mass, and always excess fat mass. Now, if you're carrying excess fat mass around, are you going to build up muscles to support that burden? Yes, of course, but that's a secondary effect, not the primary effect.
Yeah, I would agree it's secondary, but I don't think it's as simple as to say when you eat too much, you just store it, because when I eat too much, and I know I'm eating too much because if I was alone at home in a normal day, put the fork down, go back to work. When I'm with friends and they prepared a big dinner, I'm just going to taste more stuff and eat more stuff. Yet I have a regulatory, my behavior the next day changes. I'm not as hungry the next morning when I go for breakfast. That doesn't happen to people who have, tends not to happen to people who are either diabetic or over fat. So the question is, in both cases, we're eating more than is normal, quote, or that we would otherwise expect, yet the results are, again, very different. One is
but you're doing it acutely, not chronically. They're chronically eating too much. You're eating too much at one meal and then compensating the next meal.
But why can't they compensate?
Yeah, maybe
that is the question.
Shouldn't discount the possibility that because there's a brain injury, there could be actually brain level control of other tissues, because the brain absolutely does have control over what happens.
I think it's pretty clear that the brain is the ultimate regulator of the whole process, which is why a point injury to the brain can throw the whole thing off.
Right, but what I'm saying is there could actually be a point of control from the brain that's telling tissues what to do, not just telling you to go out and eat more.
Yeah, I think there's a central and peripheral interaction there that I think we shouldn't assume isn't operational unless we can demonstrate it's not. And you can definitely interfere with the CNS and atrophy certain tissues in the body, right, at the most basic level. So I wouldn't want to assume that a hypothalamic injury is going to change behavior and then change tissues. It could be that, or it could be also that it changes tissues and then the behavior adapts. And I think therein lies the causal order of those events. That's where I think Gary disagrees with Hall and Guillenet with regards to that. He's saying, well, the peripheral effects, even when you injure the brain, are what's determining this, and it's not necessarily behavior first. Right. I think that point matters if you're trying to have a theory of obesity.
I mean, I think in hypothalamic injury, clearly behavior is following a hormonal signal. The hypothalamus is not doing what it's supposed to be doing.
Right.
Right. Which is regulating the process via the hormones it secretes. And, you know, the result of that is you're ravenously hungry. So your behavior follows. Yeah.
And to get back to the acute versus chronic point you made, which I think is a good one. So if we take, again, this is an example I've used multiple times. It's kind of informative to me, but we know that cannabis will give you the munchies, and it does it acutely. Yet people can consume it chronically and still not suffer the dysregulation that's apparent in obesity. They have spikes in hunger, so they change the amplitude of the wave. They can exaggerate the amplitude, but the trough of the wave is also bigger. You tend to compensate your intake. So that's kind of interesting to me, because if you said, okay, I'm going to test this theory that I'm going to take something that's going to make me overeat pretty reproducibly, and I'm going to do it, I don't know, for a whole year or something, and I'm not going to get fat. And I'm like, damn, like that hypothesis is
we
pretty...
all know people like that.
Even better, chronic cannabis use is associated with lower body weight, not higher body weight.
Right.
But cannabis is a very messy thing, right? There's a lot of chemicals in there. I think there are the order of somewhere over 100 different cannabinoids in when you're smoking marijuana. I mean, the better example, if you're trying to look at the effect of exogenous cannabinoids, is look at what they give to people who they medically want to make eat more, right?
Dronabinol.
Which is synthetic THC. And that's what you give to people with, I'm not sure if it's indicated yet for anorexia, but they do it for cancer patients with cachexia, which is chronic wasting, and also for HIV patients who can't eat. So it's a medically recognized treatment to cause someone to chronically increase their energy consumption to increase their body weight. And it's been approved since, I think, the 1990s.
Yeah, so that's about right. But you're still, even if it's a more complex product and you can isolate THC, you're still reproducibly getting people who will eat even after their meal is over. So that's not an effect of the entourage effect, which is a thing with marijuana. So even if you have straight THC, which is very commonly sold in Colorado and other states, right. It's just THC. It's not the whole plant extract. You don't see these people becoming obese. So I'm saying, cannabis is complicated.
Is there a study showing that?
I mean, no, there's not a study showing that. But you can. I know enough people where they smoke a lot, and if this had an obesogenic effect, you would have to see it in them. You just would have to. It's not like, like these are serious smokers.
So we have divergent experience here. We have the medical literature showing one thing and the anecdotes showing another.
Those are two different things, though, because the medical literature that you brought up is about correcting underweight. It's not about inducing overweight, exactly. And those could be different.
That's a fair point. That's a fair point. So where to go next? So I wrote, as you two are probably aware, a long post on this, and one of the most compelling things I found is the data on gastric surgery, gastric bypass surgery. And there are a couple of different types of gastric bypass surgery of varying degrees of efficacy. The most interesting one was the Roux-en-Y gastric bypass, in which they do a bunch of rather dreadful things to your intestinal tract one of which is to bypass most of your stomach and a good part of your upper small intestine. And that has very interesting effects because the first thing that happens is it apparently resets your fat set point, right? And simultaneously, not only does it reset the fat set point, in the animal models they've put together to try and figure out what's going on here, the animals eat less initially, but not long term. What causes the weight loss long term is it increases your total energy expenditure.
Mm.
Right. So it
Yeah.
seems to be controlling both of those set points at the same time. You initially eat less, your body fat starts going down, and then shortly thereafter, you start burning more energy, and that's what ultimately causes you to lose the weight loss.
And in essence, you're disrupting the L and K signaling that's present in that person, the L and K cells in the upper intestine, which have an enormous effect on insulin secretion, which then, as you mentioned earlier in the conversation, if you can bring it down low enough, will liberate fatty acids and lead to behavior changes.
But
is that
if you give them a endocannabinoid, you eliminate the effect of the surgery.
Is that 2AG? Is that
okay. 2AG, or yeah, I think it's 2AG, or maybe anandamide. The two of them very closely related. So it doesn't actually have any immediate, insulin's not the thing that's driving that effect. It's the endocannabinoid system.
I have a question about it, Tucker. Did you say first they eat less and then their energy expenditure goes up? Or is it the case that the energy expenditure goes up immediately and they eat less because that energy that they're expending is coming from fat tissue, and then the energy expenditure stays high enough to deal with incoming food?
Well, they don't have any incoming food, right? I mean, the first thing that happens in that surgery is you fast for a while, and you have to, for the healing process to take place, obviously. But then after a little while, the normalized energy consumption goes down immediately, of course, but then it tends to go back up. And long term, what they see is that it's this increased energy consumption that's happening. And if you give them the endocannabinoid, the energy consumption goes down again, and they start gaining weight again.
Right. I guess what I'm trying to clarify, I'm not quite understanding if the energy expenditure goes up along with the reduction in, you said
it takes a little, if I remember correctly, it takes a little while for the energy expenditure to start increasing. It doesn't happen immediately after the surgery. It's not, and again, typically the result of this surgery minus the effect on the endocannabinoid system is that your energy expenditure goes down as your food consumption goes down, right? Here it's going up as your food consumption is going down.
Right.
So how do you separate the fact that they're fasting during that time?
Well, the fasting is a big unavoidable confounder, unfortunately. Somebody cuts your tummy apart, they've got, it's got to heal. It happens pretty quickly, but it's not overnight. And
they don't do enteral feeding with those people? They just think it's,
not in the rodent models and not in the people either. They, because, remember, these people are grossly obese to start with. That's why they're having the surgery. They can certainly, burning your own body fat is a total parenteral feeding protocol, basically, in the short term.
Right. Yeah. It'd just be interesting to see that in the animal models, if they could essentially, is it really just the anatomy, or is it the change in the anatomy plus the fasting that accounts for?
Well, and that's one of the interesting things, is the surgery doesn't always work in people or in the animal models. And when it doesn't work, it seems to be the endocannabinoid I mean, essentially what they're doing is they are cutting the connection between the hypothalamus and the intestinal tract. So you have sensors in your fat sensors in your tongue that tell your brain what fats you're about to eat. And that
It's
triggers a release.
texture-based.
It's not texture-based.
That's what Mark Schatzker was saying. It's texture-based, unlike the other senses.
Yeah, Di Patrizio and all went through by fat types, and one of the fats that they used was mineral oil, which has no caloric value, right? So that it's not the texture at all. It's literally you have CD36 receptors, the same receptors, incidentally, that dispose of oxidized LDL in your tongue, right? And you are, it seems, that sends a signal to your hypothalamus, which sends a signal to your gut that says, start releasing the hunger hormones. You're getting a load of two specific fats, right?
Okay. Well,
and now it's interesting. There are two ways to trigger that endocannabinoid release in your gut. One is by not eating, right? The other one is by eating one of the two fats that stimulates an endocannabinoid release in your gut.
So you can get hunger signals from two totally opposite inputs, essentially.
Yes, but the mechanism is identical. And, you know, it's kind of an interesting aside. That signal depends on the fat composition of the lining of your gut. And it makes me wonder if the reason people who fast longer term stop experiencing hunger after a couple of days is because they have run out of the substrate in the lining of their gut to produce the hormone that would make them hungry.
Right, because the substrate in the line, the lining of their gut is going to be eaten up by our gut bugs, essentially.
No, not the gut bugs. The body is going to is producing the I'm hungry signal. Okay. And it's only got a limited amount of those fats in the lining of the gut. Right. Once it breaks them all down, it can't make any more. It's the body's entirely dependent on diet for those fats.
Okay,
that's a hypothesis. I think it could be an interesting explanation of why people, you know, something that seems counterintuitive. Why would you fast for a week and you're only hungry for 2 days? What about the rest of the time?
Right. Yeah. But, okay, that's interesting. I have to think more about that, because a lot of stuff changes when you fast. Like your immune system gets a big part of it gets eaten up, essentially recycled. It's another way of putting it.
Right.
And since a lot of we have mucin degrading bacteria that feast on your gut as a normal process, I was wondering if that was getting gobbled up during the fast, but it's not. That's not what you're saying.
Yeah, these are the phospholipid membranes of the cells in the gut. So it would be under the mucin.
Okay.
You know,
interesting.
There was a long time where when I was ketogenic, I assumed that the lack of hunger thing that is supposed to kick in at 2 to 3 days would have already happened for me. But when I did play around over the last couple of years with some extended fasting, I found that that's not at all the case, and I did have a very noticeable difference. I did have a noticeable difference at day 2 to 3 on hunger, where it became easier, even though I was already keto adapted. So maybe something like gut lining effects could be part of that.
How long did you fast? The most you did?
The most I've ever fasted was 10 days.
Oh wow.
And to be clear, that included like some broth, so it wasn't like completely nothing but water. But even so, I did notice a difference at the 2 to 3 day mark. It didn't persist though. I got hungry again, so it was actually kind of miserable. Yeah. But I think I'm currently have impaired fasting ability right now due to some metabolic issues. I know that when I was a lot healthier, I could fast more easily. And so maybe that's part of it as well. I'm not sure.
Well, if it makes you feel any better, I've never been a big fan of fasting, and I've never tried to fast for any. I'm too
I'm
much
not
of
a
a wimp.
fan of
I'm like,
it.
I'm hungry. I need something to eat.
I'm not a fan of it, but I felt it was my duty to give it a try a couple
Mm,
times in the past year, just because I've had metabolic issues and I wanted to try some different things. But
mm,
I'm in agreement with you. I mean, most of the benefits that can come with fasting can be achieved just by being ketogenic and not
Right.
eating foods that are irritants.
Yeah.
mm.
Yeah. No, I've never seen a point
Yeah.
to longer term. I mean, short term fasting, less than 24 hours, I guess really isn't fasting. That can be helpful, like if you're traveling and you can't get any decent food to eat. But
Mhm.
at any rate, so the results of the surgery, I think, are pretty suggestive that there is a couple of set points that we're talking about, a metabolic set point and a fat set point, and the surgery resets both of those through what seems to be a common mechanism.
It's interesting because when I read those two-part blog posts of yours, well, first of all, I told you you should publish those. You should write them up and publish those because they're really good, very nice overview of the whole topic. And I haven't seen it in the literature presented quite that way. So I think it's
Well,
great.
I've been asked to do that. It's on my to-do list.
Cool. That's good. But it's interesting because reading through it, I sort of felt that you could like chisel out the food reward part, and you'd be left with as great an explanation of obesity and just a bit more parsimonious. So maybe tell me why I'm wrong about that.
Well, first explain to me exactly what you are saying that you could chisel out the food reward part. And let me just
Because
say something here. I mean, food reward is a term in our community that's very tightly tied to Stephan Guyenet. And when he abandoned his idea of linoleic acid being involved in obesity and turned the corner to the food reward thing, I was pretty pissed off because I thought his whole food reward idea was pretty stupid. So I approached this from, I wouldn't even say a skeptical point of view. I mean, I like Stephan a lot. I owe him a lot because of his early research, but I wasn't even quite skeptical towards this hypothesis. I would say I was antagonistic towards it.
That's nice background.
Yeah. So I was, when I started this project, it was supposed to be here's what's really causing it. Oh, Stephan. And then I kind of realized, wow, they're both right. They're working, one's the mechanism that describes the other. So, so explain how you think you could peel out or extract the food reward piece of it.
Because the examples you gave with bariatric surgery, the examples you give with linoleic acid, the whole explanation, because you use many different models, you use rodent models, you use human data, and I think you make a very good case for how linoleic acid, through many different ways, through 4-HNE, through the hunger hormones, through the endocannabinoids. I mean, you really lay out many different ways in which you can have this obesogenic effect. And for me, it's a very convincing set of arguments. Personally, I would add in the particular structure of carbohydrates, meaning the flours and the sugars, especially those dissolved in liquid. And to me, I see linoleic acid affecting the insulin sensitivity dial on the adipocyte, and then the carbs coming in and just jacking up insulin. And you've got this perfect storm where you're making the fat cell more sensitive to insulin, and then you're bringing in more insulin, and you've got this perfect storm that, in my understanding, fits a lot of the epidemiological literature, meaning when these things were introduced, like it kind of fits the timeline as well, which is really, really encouraging. And you have all this like very big piece of evidence, this big piece of evidence. And then I think, I feel like the food reward part is sort of shoehorned in there to be like, and people get more hungry and eat more. I'm like, I just don't see the need for it. And maybe I'm missing something. Maybe there's some explanation that I'm not getting in what you intended to write. But to me, it was like, this is enough. Like, you don't need to tell me why people are eating more at this point. You've just told me what's happening to their fat, essentially.
Mm-hmm.
Okay, so one of the neat studies in there, and I really didn't get into this at all, except to mention that they found out that their control was invalid because they were feeding them sugar. Sugar clearly, especially from what I've seen in the literature in humans, liquid sugar, right? So Coke,
Yeah.
definitely operates on the same pathway in the body, right? And what they realized was that they were trying to isolate the endocannabinoid effect, and they were seeing the same thing in the control arm because they were feeding them a diet with too much sugar in it. And a lot of these researchers have since altered the diets that they're using to go from this D12492, which was a pretty low carb diet. I think it's like 7% carbohydrate, mostly fats, or 7% sugar, mostly fats, to D12451. I'm not getting that correct, I don't think, but that's, quote, a more Western diet where they have fats and sugar, a higher proportion of sugar than the other diet. The important thing to note is the D12492 diet has been used in thousands of studies, and it's very effective at obesogenic diet. So yeah, there's definitely a pathway where liquid sugar specifically causes a reward pathway that leads to obesity. It's not very big. They've looked at it in human children, right? Sugar as part of food doesn't seem to have any effect at all, which is kind of interesting. For the starch question, if you were going to see, I mean, Gerdossi, I'm calling him by his Twitter handle. Gabor has a fantastic paper that's really quite amazing, where they look at starch modules versus ground up starch, and the ground up starch has a effect that's very different from the unground starch, right? So when was that introduced into the human diet? It was in the 1600s. It was when mass milling of flour, industrial milling of flour was invented in Eastern Europe, oddly enough. And it rapidly spread all over Europe and then all over America. Now, what didn't follow that was mass pathogenic obesity of the sort that we're seeing now. So you've got a several hundred-year gap between the purported cause and the effect, right? And we've also got, what was fascinating, if you look at the glycemic effect of different starches, clearly cooking starch, the whole point of it is liberating the glucose from the starch chain, which we can't digest all that well. What the amazing thing about Gabor's paper was that they, even though they could digest the starch, it seemed to have a different effect when it went onto the tongue as glucose. So there could be a glucose sensor there that's triggering them, that, people don't generally eat liquid glucose the way we do liquid sucrose. So we might see that if people consume that in quantity. I haven't seen anything looking at that particular aspect of it.
I have a criticism of the concept of palatability. I'm going to suggest that it might be circular, because what it seems to say is that palatability, if a food is palatable, is extra palatable, that means that it doesn't lead to satiation, and it might even cause you to want to eat more, right?
Well, there's palatability, and then there's palatability is an aspect of the food reward idea, but yeah. So you can have palatable foods that you don't eat to obesity.
So it's the reward value that matters?
It's essentially, back to where we started this off, what is causing you to overeat to the point where you're getting overweight?
So I would rephrase that as what about what you're eating is causing the variable under set point regulation to not meet its set point. So if it were, for example, energy expenditure, is there something about what you're eating that is causing energy expenditure to dip despite you're eating more of it? So in the case of sugar, you could say it's causing an acute insulin response, which is suddenly making fatty acid oxidation go down. So instead of making you less hungry, it makes you more hungry in that case. You could imagine like something that behaviorally looks like this food is really rewarding being explained by desire to eat more and more, because the more that you eat it, the less satiated you become. I know that food reward has some connection to dopamine, and maybe there are studies that enforce that connection, but I'm still not completely convinced that that isn't like an epiphenomenon.
Yeah, I'm not either. And Mark goes through some very elegant rodent experiments where they show that dopamine and reward just do not predict weight gain in rodents. And they have a very nice experiment where they mismatch. So they had a sweetness and a carbohydrate load in water, and they basically mismatched them. So you had some things that, so everything was made to taste like 75 what was it, if I'm not getting this wrong, 75 grams of glucose, and then they changed the carb content, and they saw that the thing where there was a normal response was when the carb content was matched to the taste, and when things were mismatched, then you had this, you know, obesogenic and quote hyper rewarding food. So to me, it really signals that it's not just how rewarding something is. It's the expectation of reward and how it's going to affect your metabolism or energy expenditure or something, you know, physiological in your body. Because I don't think that people who let's say they're obese and then they lose their weight, I don't think anyone says, yeah, food is less rewarding now. I don't eat it. I don't have as much pleasure. I never hear that. And if we're meant, you know, I mean,
I like to refer to this way of eating as the cheating diet, because you eat so much better than you did before when you were eating junk food. So
yeah.
I would certainly argue it is more rewarding to eat this way, even though, you know,
Right.
the excess weight tends to go away.
So do I. I really think I could, you know, confidently say I really do enjoy my food. I talk about it, I taste it, you know, all these things to show that I'm enjoying it more. And it's not, I can never link it to obesity. And I think that those are some very simple, maybe, you know, to my mind, falsifications of this idea that it comes down to the pleasure you get from the food, and that this will determine how much you eat of it, and how much you eat of it is going to determine how much fat you put on.
Right. One of the more interesting studies that I touched on, I don't know if I got into this aspect in the blog post that I did. They looked at feeding rodents the, you know, whatever standard obesogenic diet they were using, and there are like 5 or 6 of them that I think I mentioned in all those posts. And they gave the rodents rimonabant, which is a drug that blocks uptake of the endocannabinoids in the gut and the brain, which was, I will mention, at one point a human-approved drug, until it turned out it had the unfortunate effect of making people want to kill themselves. But, you know, efficacy was demonstrated in human for the obesity endpoint prior to them yanking it from the market. So what happened to these mice when they were given the alternative between the obesogenic diet and the non-obesogenic diet, and they were on rimonabant? They still picked the obesogenic diet. They didn't pick it as quickly, right? They kind of wavered back and forth a little bit, but at the end they wound up eating the obesogenic diet because they prefer the fat, but they didn't get obese.
Right. And what fats were in that diet?
They use, I mean, again, I'm going from memory. I think it was D12492. Most of the studies I looked at were that diet. You know, that's the one that Peter Dobromilsky referred to as the cookie dough diet after Stefan said that the rats love it. You know, it tastes like cookie dough. I guess Stefan's tried it. So it's lard and soybean oil, and it tends to have a pretty high dose of omega-6 fats. And then, you know, because of how they feed pigs, and obviously there's a lot of that in soybean oil. And then it's, the next biggest fat would be oleic acid, AMUFA, and then there's a couple saturated fats in there. So that was really interesting, because what that meant was that the reward pathway was still operative, right? Even though they blocked the hyperphagia aspect of it, they still found that diet more rewarding, but it wasn't obesogenic any longer.
That is interesting.
So
I have to look in that.
Whatever, there's a decoupling between the obesogenic effect and the reward, and also whatever the drug was doing was able to compensate for the lack of oxidation that was happening.
Well, rimonabant has the effect of, you know.
I'm not familiar with that drug, sorry. What does it do?
Okay, so rimonabant is an CB1 receptor, the right cannabinoid receptor number 1, which is the one that seems to control hyperphagia in animals and humans.
It's like an agonist or antagonist?
And
it's an agonist.
It's technically a reverse agonist, and I'm saying that out of memory, and I still can't explain the difference between an antagonist and a reverse agonist. But yes, it has the effect of blocking the uptake of the drug-like substance by the receptor. And you know what they've, just as kind of an aside, what they're experimenting with nowadays are peripheral endocannabinoid antagonists. And they don't have nice names like rimonabant, but I mentioned them in my paper, that block it not in the brain, but everywhere else, because where you want to block it apparently is in the gut. That's where the signal happens.
Fascinating.
So yeah, there's, you know, a dichotomy between reward, meaning, gee, this tastes good, I'd love to have it for dinner tomorrow, and this obesity inducing signal that we are getting. And in the animal models, you know, and also the indication in the human models, as far as we can get, is that it's this endocannabinoid pathway, which is upstream of what's happening with dopamine, right? And it's interesting because in rimonabant also has the effect of blocking the desire to consume addictive drugs like cocaine in primates, right? So it speaks to a mechanism for the food addiction phenomenon that a lot of people talk about and complain about. And I think it's a validation that, you know, you'll hear people say, oh, there's no such thing as food addiction. Well, we have a drug that we can use to block addiction. And the same mechanism blocks what you would call food addiction, which is eating to obesity.
So I think we have to bring this to we have to
on
bring
that note.
Close. Yeah, on that note. But no, there's a ton to explore there, and thanks so much for your time, guys. I'm sure we'll continue this on Twitter.
Amber, do you want to get a last word in? I don't want to leave you without that opportunity.
No, I just want to say, yeah, that looks like something to explore further. And it's been great talking to you guys. And in person, well, we're not really in person, but face to face, let's say, is so much more productive than anything we could do on Twitter, much as I love Twitter.
Yeah,
indeed.
I agree.
So thanks for doing this with me.
Great to see you guys again.
Thanks for accepting. And yeah, I'll see you on Twitter, and I'll put this up tonight. So yeah, people will let us know what they think about it.
Great. Thanks, guys.
All right.
Thank you.
Bye-bye.
Bye.